Good morning students, welcome to my video lecture Brahmanad. Om Shanti Shanti Shanti. In last class we discussed complex number. That means fundamental of complex number, integral power of I, equality of two complex number. Okay, so I is equal to square root of -1. I square is equal to -1. So I to power 4 into integer is equal to +1. I to power 4 into integer plus 1 is equal to I to power 4 into integer plus 2 is equal to -1. I to power 4 into integer plus 3 is equal to -I. Okay, today we are going to discuss algebra of complex number and conjugate of complex number. Okay, so first algebra of complex number. Algebra of complex number. Algebra means addition, subtraction, multiplication and division. Okay, let z1 is equal to x1 plus iy1 and z2 is equal to x2 plus iy2. Okay, where x1 comma x2 comma y1 and y2 all are belongs to set of real number R. Both z1 and z2 belongs to set of complex number C. Okay, the first addition of two complex number. Addition z1 plus z2 is equal to x1 plus iy1 plus x2 plus iy2. So is equal to add real part and imaginary part plus imaginary part. So this is x1 plus x2 plus iy1 plus iy2 means I is common. I into y1 plus y2. Suppose this is capital X plus I into capital Y, where capital X is equal to x1 plus x2 belongs to real number R and capital Y is equal to y1 plus y2 also belongs to real number R, because sum of two real number is also a real number. Sum of two real number is also a real number. So therefore z1 addition of two complex number is also a complex number. Addition of two complex number is also a complex number. A complex number. Sum of two complex number is also a complex number. Okay, the properties. Let z1 comma z2 belongs to set of complex number C. Set of complex number C. So first closure property. Closure property. What is closure property? Now since z1 and z2 both belongs to set of complex number C, so their sum also belongs to set of complex number C. z1 belongs to C, z2 belongs to C. So this implies Z1 plus Z2 belongs to C. Okay, Z1 plus Z2 belongs to C. नहीं, Z1 plus Z2 also belongs to set of complex number C. So satisfied closure property. Next, commutative property. Commutative means what? Z1 plus Z2 is equal to Z2 plus Z1. Z1 plus Z2 is equal to Z2 plus Z1. Next, associative. Z1 let Z1 comma Z2 comma Z3 belongs to set of complex number C. So Z1 plus Z2 plus Z3 is equal to Z1 plus bracket Z2 plus Z3. This is the associative. So satisfied also associative property. Next, existence of additive identity. Additive identity. Let Z belongs to set of complex number C, then there exists a complex number 0, that is 0 plus I into 0, such that Z plus 0 is equal to 0 plus Z is equal to Z. Therefore 0 is equal to 0 plus I into 0 is called additive identity of Z. Additive identity of Z. Additive identity of Z. Okay. ओडिया कौन कहते जोगात्मक अभेद. नेक्स्ट, एक्जिस्टेंस ऑफ एडिटिव इनवर्स. एक्जिस्टेंस ऑफ एडिटिव इनवर्स. Existence of additive inverse. Okay. Let Z belongs to C, set of complex number C. There exists a complex number, then there exists a complex number minus Z belongs to C, such that Z plus of minus Z is equal to minus Z plus of Z is equal to 0, that is 0 plus I into 0. 0 plus I into 0. Hence, minus Z is the additive inverse of Z. Hence, minus Z is the additive inverse of Z. Okay. Next, difference or subtraction. Difference or subtraction. Z1 minus Z2. So Z1 is x1 plus IY1 minus x2 plus IY2 is equal to x1 minus x2 plus I into y1 minus y2, means real part minus real part plus I into imaginary part minus imaginary part. So is equal to x1 minus x2 plus I into y1 minus y2 is equal to, suppose this is a capital X plus I into capital Y. where capital X is equal to x1 minus x2 belongs to set of real number R, and capital Y is equal to y1 minus y2 also belongs to real number R, because the difference of two real number is also a real number. Therefore difference of two complex number, therefore difference of two complex number is also a complex number, is also a complex number, is also a complex number. Okay, difference of two complex number is also a complex number. Okay, next multiplication. Z1 into Z2. So what is Z1? x1 plus iy1 into x2 plus iy2, x2 plus iy2 multiply in general form. This is x1 x2 plus x1 into iy2 plus iy1 into x2 plus iy1 into iy2, that is x1 x2 plus second and third term I is a common. This is x1 y2 plus y1 x2 plus this is I square y1 y2, but I square is a minus 1, so put here minus 1. This is x1 x2 plus I into y1 x1 y2 plus y1 x2 minus y1 y2, because I square is equal to minus 1. So is equal to, first keeping all the terms of means real part are one side, means that is x1 x2 minus y1 y2 as a one term, this is called real part, plus I, coefficient of I is equal to imaginary part, so I into x1 y2 plus y1 x2. So this is equal to capital X plus I into capital Y, where capital X is equal to x1 x2 minus y1 y2 belongs to set of real number R, because the product of two real number is also real number and difference of two real number also real number. Next, y is equal to x1 y2 plus y1 x2, y1 x2 belongs to real number R, hence product of two complex number is a complex number, hence product of two complex number is also a complex number. Achha, here ReZ1 Z2. ReZ1 Z2 means what? x1 x2 minus y1 y2. Real part of Z1 Z2. Real part of Z1 Z2 is what? x1 x2 minus y1 y2 is equal to, what is x1? x1 is real Z1. What is x2? x2 is real Z2. x2 is real Z2 minus what is y1? I am Z1 and y2 I am Z2. This is ReZ1 Z2 means ReZ1 into ReZ2 minus I am Z1 into I am Z2. Next, I am Z1 Z2. I am Z1 Z2 means what? x1 y2 plus y1 x2. So is equal to, what is x1? ReZ1. What is y2? I am Z2 plus y1 I am Z1 x2 ReZ2. So this is I am Z1 Z2. This is called I am Z1 Z2 is equal to ReZ1 into I am Z2 plus ReZ2 into I am Z1. Okay. Next, properties of multiplication. Properties of multiplication. Properties of multiplication. First property, closure property. Closure property. Closure. Closure property means what? Now let Z1 belongs to complex number C. Z2 also belongs to set of complex number C. Their product also belongs to set of complex number C. It is called closure property. Let Z1 belongs to C. Z2 also belongs to C. So this implies Z1 into Z2 also belongs to C. Also belongs to C. Okay. So it is called a closure property. Product of two complex number is a complex number. Already we checked. नहीं कि हम check कले बर्तन. Next, commutative. Commutative भी satisfy करिबो. Commutative. Z1 into Z2 is equal to Z2 into Z1. Okay, Z1 into Z2 is equal to Z2 into Z1. You may check it. Similarly, associative. Associative. Let Z1, Z2, Z3 belongs to set of complex number C. So first Z1 into Z2 करिबो, then multiply करिबो Z3 is equal to Z1 into bracket रे Z2 into Z3. This is called associative property. ये भी satisfy करिबो. Next, multiplicative, existence of multiplicative identity. Existence of multiplicative identity. Multiplicative identity. कौन मल्टीप्लाई कले वैल्यू चेंज हेनी व्हाट नंबर we multiply with the given complex number, the complex number becomes same. Okay, let Z belongs to set of complex number C, then there exists a complex number one, that is 1 plus I into 0. There exists a complex number 1, that is 1 plus I into 0, such that Z into 1 is equal to 1 into Z is equal to Z. Therefore 1 is equal to 1 plus I into 0 is the multiplicative identity of Z. 1 or 1 plus I into 0 is the multiplicative identity of Z. Next, existence of multiplicative inverse. Existence of multiplicative inverse. Existence of multiplicative inverse. कौन मल्टीप्लाई कले 1 आसो है सपोज Z is a complex number, there exists another complex number 1 by Z such that Z into 1 by Z is equal to 1. 1 means 1 into I into 0. Let Z belongs to C, set of common C, then there exists a non-zero complex number let Z belongs to C minus curly bracket 0 means Z is a non-zero complex number. Let Z is a non-zero complex number. Then there exists a complex number 1 by Z such that Z into 1 by Z is equal to 1 by Z into Z is equal to 1, that is 1 plus I into 0. Therefore 1 by Z is a multiplicative multiplicative inverse of z. Okay, now 1 by z means 1 by x plus iy. Let z is equal to x plus iy. Okay, so is equal to multiply x minus iy. So is equal to x minus iy divided by multiply this x square, okay, plus y square iy into minus iy plus I into yx minus xy, yx minus xy plus y into yx minus xy. This is the multiplicative inverse of z. Multiplicative inverse of z. Okay. Implies 1 by z is equal to x divided by x square plus y square plus I into yx minus xy. Sorry. Okay, this is cancel, xy yx cancel, तो ये cancel हो खाली एति रहिबो. Okay, x by x square plus y square plus I into minus y by x square plus y square. This is the multiplicative inverse of z. Multiplicative inverse of z is denoted by z inverse or 1 by z. Okay, for each note, for each non-zero complex number, non-zero complex number has unique multiplicative inverse, has unique multiplicative inverse. Okay, for each non-zero complex number has unique multiplicative inverse. Next, distributive law. Distributive law let z1 comma z2 comma z3 belongs to set of complex number C. Then z1 into z2 plus z3 plus or minus over addition, also multiplicative over addition, or also multiplicative over subtraction, is equal to z1 into z2 plus or minus z2 into z1 into z3. z1 into bracket z2 plus or minus z3 is equal to z1 into z2 plus or minus z1 into z3. This is called distributive law, multiplication over addition or subtraction. Okay, these are the properties of multiplication of complex number. Next, division of complex number. Division of complex number. Division of complex numbers. z1 by z2, z1 by z2. तो व्हाट इज z1 x1 प्लस iy1 डिवाइडेड बाई x2 प्लस iy2। तो x1 प्लस iy1 इंटू डिनोमिनेटर गिवन x2 प्लस iy2 तो डिनोमिनेटर कंटेन्स x2 प्लस iy2। तो मल्टीप्लाई बोथ न्यूमरेटर एंड डिनोमिनेटर बाई x2 माइनस iy2। डिनोमिनेटर देखिए चेक करियो कौन अच्छी थी y2 आगे कौन साइन अच्छी प्लस अच्छी ना माइनस अच्छी प्लस थे माइनस द्वारा मल्टीप्लाई करिवो माइनस थे प्लस द्वारा मल्टीप्लाई करिवो आई रो साइन देखियो आई रो साइन प्लस अच्छी कहला आई साइन टाक माइनस करके मल्टीप्लाई करियो बोथ न्यूमरेटर एंड डिनोमिनेटर यदि आई आगे माइनस अच्छी तो प्लस रे मल्टीप्लाई कर डिवाइड करियो ओके। तो दिस इज x2 माइनस iy2 divided by x2 plus iy2 into x2 minus iy2। तो इज इक्वल टू मल्टीप्लाई दिस x1 x2 plus I into y1 x2 minus I into x1 y2 minus I square into y1 y2 divided by a plus b into a minus b a square minus b square x2 square minus I2 iy2 रो होल स्क्वायर a plus b into a minus b कले a square minus b square। तो दिस इज x1 x2 प्लस I कॉमन कर दे y1 x2 माइनस x1 y2 I स्क्वायर मीन्स -1 तो माइनस हाफ माइनस दैट इज प्लस y1 y2 डिवाइड बाय x2 स्क्वायर माइनस I स्क्वायर दिस इज I स्क्वायर y2 रो स्क्वायर I स्क्वायर y2 रो स्क्वायर। तो इज इक्वल टू x1 x2 प्लस y1 y2 प्लस I इंटू x2 y1 माइनस x1 y2 डिवाइडेड बाई x2 स्क्वायर प्लस y2 स्क्वायर बिकॉज I स्क्वायर इज -1 तो माइनस माइनस प्लस। तो सेपरेट द रियल एंड इमेजिनरी पार्ट x1 x2 प्लस y1 y2 डिवाइड बाई x2 स्क्वायर प्लस y2 स्क्वायर प्लस I इंटू x2 y1 माइनस x1 y2 डिवाइड बाई x2 स्क्वायर प्लस y2 स्क्वायर इज इक्वल टू कैपिटल X प्लस I इंटू कैपिटल Y वेर कैपिटल X इज इक्वल टू x1 x2 प्लस y1 y2 डिवाइड बाई x2 स्क्वायर प्लस y2 स्क्वायर बिलोंग्स टू सेट ऑफ रियल नंबर R एंड कैपिटल Y इज इक्वल टू x2 y1 माइनस x1 y2 divided by x2 square plus y2 square also belongs to set of real number R. Therefore, division of two complex number is also a complex number. Therefore, division of two complex number is also a complex number. Is also a complex number. Okay. Division of two complex number is also a complex number. Okay. Express in x plus iy form. Question number 1 and 2 given. First question number 1 देख लीजिए. Question number 1 solution 1 by 1 minus 4i minus 2 by 1 plus I whole into 3 minus 4i divided by 5 plus I. This is the question. X plus iy form means x and y both are a real number. Okay. तो सही फॉर्म एक्सप्रेस करिबा. तो फर्स्ट फाइंड द एलसीएम. दिस इज 1 minus 4i into 1 plus I. तो 1 plus I minus 2 times 1 minus 4i whole into this is 3 minus 4i divided by 5 plus I. तो इज इक्वल टू मल्टीप्लाई टू कॉम्प्लेक्स नंबर इधर को मल्टीप्लाई कर दिया. तो ऑर्डिनरी मल्टीप्लाई करो 1 into 1 1 minus 4i plus I minus 4i square. Okay. Next 1 plus I minus 2 plus 8i whole into this is 3 minus 4i divided by 5 plus I. So is equal to 1 minus 2 minus 1 I plus 8I 9I divided by this is 1 minus 4I plus I minus 3I 4I square is minus 1 so minus 1 into minus plus so plus 4 into 3 minus 4I divided by 5 plus I. Okay, so is equal to minus 1 plus 9I divided by 1 plus 4 5 minus 3I into 3 minus 4I divided by 5 plus I. So multiply the numerator and then multiply denominator. So is equal to minus 1 into 3 minus 3 minus 1 into minus 4I plus 4I 9I into 3 27I 9I into minus 4I minus 36I square divided by 5 into 5 25 5 into plus I 5I minus 3I into 5 minus 15I minus 3I into I minus 3I square. So is equal to minus 3 plus 31I 27 plus 4 31I this is plus 36 because I square is minus 1 divided by whole divided by 25 plus 5I minus 15I means minus 10I this is a plus 3 because I square is minus 1 so minus plus so this is 36 minus 3 36 minus 3 means 33 plus 31I divided by 25 plus 3 28 minus 10I. Okay, now denominator contains 28 minus 10I. So multiply both numerator and denominator by 28 plus 10I. तले जहाँ थी आई साइन देख आई साइन कौन माइनस अच्छी तो आर अपोजिट साइन हम प्लस मीन 28 प्लस 10 मल्टीप्लाई कर डिवाइड कर तो इज इक्वल टू 33 प्लस 31I इंटू 28 प्लस 10I डिवाइडेड बाई 28 माइनस 10I इंटू 28 प्लस 10I. ओके, तो इज इक्वल टू मल्टीप्लाई 33 इंटू 28 तो इज इक्वल टू 33 इंटू 28 नेक्स्ट प्लस 31 इंटू 28I 31 इंटू 28I प्लस 33 इंटू 10I मीन 330 33 इंटू 10I प्लस 31 इंटू 10I स्क्वायर डिवाइडेड बाई 28 होल स्क्वायर माइनस 10I होल स्क्वायर 28 होल स्क्वायर माइनस 10I होल स्क्वायर. ओके, तो इज इक्वल टू 33 into 28 means 924 next 31 into 28 means 868I plus 330I plus 310 I square means minus 1 I square means minus 1 divided by 28 square means 784 minus plus because I square means minus 1 10 square means 100 तो 924 minus 310 936 614 okay plus 868 plus 338 30 means 98 11 1198I divided by 884 तो simplify 614 divided by 884 plus 1198 divided by 884I. Okay, so this is the x plus I into y form, x plus I into y form. आगु simplify this means आउरी cancel करि पार हला देख cancel कर जति आसीबो ओके तो ये हमारे कौन which is in x plus iy form, which is in x plus iy form ओके तो reduce करिया कहले x plus iy तो ये हमारा x plus iy form ओके these are the homeworks for you. Prove that the following complex number is purely real. Purely real means imaginary part is 0. Imaginary part is कौन हम 0 आसीबो खाली real ही आसीबो. Find x and y if x minus 1 divided by 3 plus I is equal to plus y minus 1 divided by 3 minus I is equal to I. Find LCM, then comparing both side. Okay, real part is equal to equating both side, real part is equal to real part, imaginary part equal to imaginary part. We get two equations, solving two equations we get the value of x and y. Similarly question number 2 ro second bit. Question number 3, express the complex number in standard form. Standard form means x plus iy form. Okay, एवजिन कराला करियो x plus iy form रे reduce करियो. Okay, next question, find the multiplicative inverse of 1 plus I root 3 whole square. Okay, so answer, let z is equal to 1 plus I root 3 whole square. Okay, first expand this. So 1 plus I square root 3 square plus 2I root 3, that is 1 minus 3 I square means minus 1, 3 plus 2I root 3. This is minus 2 plus 2I root 3. So this is z. Okay, therefore multiplicative inverse of z is 1 by z. Therefore 1 by z is equal to 1 by minus 2 plus 2I root 3. But it is not in standard form. Standard form means x plus iy form. It is not in x plus iy form. So reduce to x plus iy form. Okay. So what is the coefficient of I? What is the sign of I? Sign of I is plus. So multiply both numerator and denominator by minus 2 minus 2I. It is जहाँ चोरी imaginary part रो sign जहाँ थिबा तार opposite नहीं कि multiply करियो. तो is equal to minus 2 minus 2I root 3 divided by minus 2 plus 2I root 3 into minus 2 minus 2I root 3. Okay, so is equal to minus 2 minus 2I root 3, the a plus b into a minus b. So a square, a means minus 2 square minus b square, b means 2I root 3 square, 2I root 3 square. Okay, so is equal to minus 2 minus 2I root 3 divided by minus 2 square means 4 minus the 4 into 3 into I square. 4 means 12I square, that is minus 2 minus 2I root 3 divided by 4 plus 12, because I square is minus 1, since I square is equal to minus 1. So is equal to minus 2 minus 2I root 3 divided by 16. So minus 2 by 16 minus 2I root 3 by 16 is equal to minus 1 by 8 plus I into minus root 3 by 8. So this is x plus iy form. So therefore minus 1 by 8 plus I into minus root 3 by 8 is the multiplicative inverse of 1 plus I root 3 whole square. 1 plus I root 3 whole square. Okay, these are the homeworks. Find the multiplicative inverse of the following complex numbers: 3 plus 4I divided by 1 plus 2I whole square, and 3 plus I into 1 minus I divided by 2 plus 3I into 5 minus I whole square. Okay, first take this is Z. Okay, then simplify this, simplify, or also take Z equal this. We can find the value of, we can find multiple of Z, that means 1 by Z. So 1 by Z means denominator becomes numerator and numerator becomes denominator. Then simplify and reduce to x plus iy form. That is the required multiplicative inverse of Z. Okay. Next, conjugate of a complex number. Conjugate of a complex number. Conjugate of a complex number. Complex number. Conjugate of a complex number. Okay. Conjugate of a complex number. When two complex numbers differ only in the sign of I, when two complex numbers differ only in the sign of I, then we say that they are conjugate to each other. Then we say that they are conjugate to each other. Okay, again, when two complex numbers differ only in the sign of I, means one is a plus ib and another one is a minus ib. So differ in the sign of I only, how other are same. Okay, when two complex numbers differ only, when two complex numbers differ only in the sign of I, differ only in the sign of I, differ only in the sign of I, then they are said to be, conjugate of each other. Conjugate of each other. Conjugate of each other. Okay. If Z is equal to x plus iy, comma x comma y belongs to set of real number, is a complex number, then x minus iy is the conjugate of Z and is denoted by Z bar or Z dash. Just change the sign of imaginary part only. Z bar is the complex number which is conjugate of Z. Just change the sign of imaginary part only. Real part same, imaginary part ro sign ta change karibo. Okay. Therefore Z is equal to x plus iy. This implies Z bar is equal to x minus iy. Just change the sign of imaginary part only. Just change the sign of imaginary part only. Okay. In other words, we can say conjugate of z, conjugate of a complex number, conjugate of a complex number is the mirror image of, is the mirror image of mirror image of complex number, mirror image of the mirror image of complex number with respect to x-axis, with respect to x-axis, and is obtained by interchanging the sign of I, obtained by interchanging I with minus I with minus I. देख टे डायग्राम कर if p bracket x comma y be a point represented by a complex number z is equal to x plus iy, then p dash bracket x comma minus y be the image, be the conjugate or image of p with respect to x-axis. देखो ठीक है, this is x, this is y, this is x dash, this is y dash. X also called real axis. X also called real axis. This is p point having coordinate x comma y. So this is the p dash x comma minus y. So p dash is the mirror image of p dash. A length समान देखो, है ना, ये 9 degree. Okay. If p lies in first quadrant, then p dash lies in fourth quadrant. If p lies in second quadrant, then p dash lies in third quadrant, and vice versa. Suppose this is point. This is minus 1 comma 2. Minus 1 comma 2 means minus 1 plus 2i. This is the p. So our image, this is z. This is z. So our image, this is z dash or z bar. The p dash minus 1 minus 2, that means minus 1 minus 2i. So if p lies in first quadrant, then p dash lies in second quadrant. If p lies in, or if z lies in first, then z bar lies in fourth quadrant, and vice versa. If z lies in second quadrant, then z bar lies in third quadrant, and vice versa. Okay. Next, properties of conjugate. Example, let z is equal to 3 minus 4i. So this implies z bar is equal to 3 plus 4i. Means change the sign of imaginary part. Z is equal to minus 2i plus 4. So implies z bar is equal to what? Z bar is equal to I रो sign कौन सी minus अच्छी तो 2i plus 4 है next z is equal to 3 minus 3 plus 4 minus 4i तो z bar is equal to minus 3 plus 4i. Okay, 4 z is equal to I तो z bar is equal to minus I. So these are the conjugate of z. Next, properties of conjugate. Properties of conjugate. Properties of conjugate. Okay, let z comma z1 comma z2 belongs to set of complex number c. So 1 property 1 z bar whole bar is equal to z itself. Conjugate of z is equal to z itself. 2 z is equal to if z is equal to z bar, if z is equal to z bar, this implies z is purely real. Z is purely real. Okay, so x plus iy is equal to x minus iy. So this implies x cancel. 2iy is equal to 0 implies y is equal to 0. Therefore z is equal to x plus iy. So implies z is equal to x because y is equal to 0. Okay. 3 if z is equal to minus z bar, this implies z is purely imaginary. Z is purely imaginary. If z is equal to minus z bar, then z is purely imaginary. 4 z plus z bar is equal to 2 real z. Z plus z bar is equal to 2 real z. Suppose z equal x plus iy, then z bar is x minus iy. Adding both, we get 2x. So what is x? X is real z. So 2 times real z. Next 5 z minus z bar is equal to I into 2 into imaginary z. I into 2 into imaginary z. Z minus z bar is equal to I into 2 into imaginary z. Okay. Next 6 z plus or z1 plus or minus z2 whole bar is equal to z1 bar plus or minus z2 bar. Z1 bar plus or minus z2 bar means conjugate of sum of two complex number is equal to conjugate of sum of conjugate of each complex number. Okay. Next 7 z1 into z2 whole bar is equal to z1 bar into z2 bar. Conjugate of product of two complex number is equal to product of conjugate of each complex number. Next 8 z1 by z2 whole bar is equal to z1 bar divided by z2 bar. Condition z2 not is equal to 0. Z2 not is equal to 0. Next 9 z into z bar is equal to real z square plus im z square. Okay. Example, let z is equal to x plus iy, z bar is equal to x minus iy. So z into z bar is equal to x plus iy into x minus iy is equal to x square plus y square. So what is x? X is real z, y is imaginary z. Next 10 ये भी कर z1 plus z2 plus z3 plus dot zn whole bar is equal to z1 bar plus z2 bar plus z3 bar up to plus zn bar. 11 z2 power n whole bar is equal to z bar whole power n. z2 power n whole bar is equal to z bar whole to power n, comma n belongs to natural number. N belongs to what? Natural number. So these are the properties of complex number. These are the properties of conjugate of complex number. Conjugate of complex number. Okay. Next class we shall do the modulus of a complex number and their properties. Okay.